So if you've ever seen an e-commerce website like this where you're trying to buy some products, you'll also see at the bottom you have some recommendation based on your previous purchase or based on other people who bought similar products to what you're trying to buy. So this is what we call as recommendation, and in this tutorial we are going to look at how to build a simple recommendation engine. So let me walk you through what we have right now. So first step is to generate some synthetic data, because we don't have access to real world data yet. So to just get our hands dirty with the recommendation modeling that we are about to do, it's much easier to just go with a simple synthetic data. So for that, I'm going to import these two libraries, which is NumPy and Pandas. So that's straightforward. Then we want to create users, products, and ratings. So let me just explain what's happening here. So for every user, I'm going to give it a user underscore and then a random string, and then we are generating 1,000 users. And similarly, we are generating like 1,000 products. And for each of them, we are going to rate them between 1 and 6. And this is what we have. And then we'll create a data frame out of it. And you'll see how this looks like in a second. So now if I open my data up in this data frame, you'll see that we have 3 columns. One is user ID, the product ID, and the rating they've given to each of the products. So this is good. So the next step is to do some recommendation modeling. So hopefully you have something like this in your business or in an e-commerce database that you have access to. So, or maybe you also have additional features here as well. So nonetheless, this is like the minimum amount of data that we would need to build our recommendation engine. So let me just minimize this. So the first thing is we can bring in train test plate, although we don't really need that in this exercise, but in the other exercises will probably be useful. So the algorithm that we're going to be using here is very, very simple. It's called Cosine Similarity. So we're just finding out similar users who have bought products in the past, and we want to recommend products that someone else have bought to someone new who haven't bought that product. So cosine similarity is a very neat technique for that. Now there are more advanced techniques like a priori algorithms and other things, but we don't have to worry about those now. Let me just bring this in, and first thing we want to do is build a user product matrix, and you'll see what this means. So this is a simple pivot table. So we have a table like this where we have all the users and then all the products they've rated in the past. So we want all the users on their separate rows. So let me just run this, and this will make more sense. And if I open my user product matrix now, so you'll see user pro 1 is here, and then all the products this user has recommended or rated in the past is all here in one single row. With this data set in place, we can run the similarity matrix on it, which is basically it's just calling cosine similarity. Really, there's not much to it. So you see that it's already done. It didn't take time at all, although the data set that we're working with is really, really small. But you can see the powerfulness of this, where if you had like 100,000 users, you can have all these products in your store, and you should be able to generate a recommendation engine out of it. And now if I look at the matrix that this cosine similarity generated, it doesn't look like it's much, but there's quite a lot of things that are happening over here, and you'll see it's like 100 columns wide, and we have loads of rows over here as well. And this is like a sparse matrix that we've been able to generate using this cosine similarity. So the next thing is, I guess, more interesting, because here we are working with predicting data, and this is what I really wanted to get to anyways, because this gives a bit more intuition on how all these algorithms and applications in real world work as well. So here is a simple function where I just give it a predict rating function, and to this we are giving the user ID, the product ID, and the matrix and the similarity matrix, everything that we've generated so far. And then the job of this is to give us a rating of the product that the user hasn't bought in the past. So for example, if we say our user is user 1 and the product ID we are interested in is product 1, let's see what this user has already rated for this product. So we see user 1 has not rated anything yet. So this means this user hasn't purchased this, right? So what if we wanted to get a prediction on how much this user would rate this product? So that is what we're doing here in this predict rating function. And let me run this first. So we have that in place, and then I can run this predict rating and then print it out. So you'll see that user 1 on product 1 will predict something like 1.18, whereas in reality it's only 0. So this user hasn't bought this product yet. So we can go through each of these lines step by step. So first, we are getting just the user index from our user product matrix data frame. And we also get the product index as well. And we run a similarity matrix and get the user index and get the user similarity scores on this and get the ratings for the target product. And then we just calculate the weighted average and sum the weight up and then bring it out as a predicted rating. So this is good, but what if we wanted to get like a series of recommendation like this on all the products that we can recommend to this user? So in that case, what we can do is build another simple function which looks something like this, where we can call it recommend products, and we get the user index, user similarity scores, and then we just loop through all the products that we have within our store or within your business, and then we try to get all the ratings for all these products into this array that we have, and then we just sort this out and then get only the top n recommended products out. So if you want top 3 products, it would just get like top 3 rated products out of this function. So let me just select all of this and run this. So we've initialized that. So again, we'll go with user ID 10 and we'll just get a recommendation on this and then also print this out. So you'll see the recommended products for user ID 10 are 13, 1, and 7. So for this user ID, the recommended products are 13, 1, and 7. So you'll see if we just look at first example over here, this user hasn't bought recommended product 1. But hopefully when we do recommend this to the user, then they'll go ahead and look at least consider buying. But this is good, but we can also get the average rating as a plot as well. So let me just do that. So we can run all of this. And if I come down here, I can just run this plot recommendation. So here, instead of just getting recommendation as the product names that we just saw, we also get a score or a rating out of it. So we see that product 13 would have the highest rating by this particular user 10, right? So this product is the most probable to be bought by user 10, and then so on. We have like 5 other products as well. So that is a very simple implementation of product recommendation. And in this case, we are using Cosine Similarity. And in future videos, we'll probably also look at using some other algorithms which are a bit more advanced and has a few more features that we can enable and use